Hello my friends, welcome to Instant Out Electronic channel. This is Uncle Misha, and today we have a calculator, this beast of a calculator on my desk. It's pretty heavy and pretty big, and I'm pretty sure it is not working. So what do we have here? We have Burroughs C3123 desktop calculator. As you see, it is in a bit in rough shape. Not all buttons are working. Looks like they had some kind of spillage on them, and looks like this power cord had some kind of flame incident right here, because looks like strain relief here is pretty bad. So what we have to do, we have to clean this thing up, take it apart, see what's going on inside, and then we will figure out if this worth our time repairing or not. If not, we're gonna just do a tear down. So let's stay together and see what's inside. Turned out to be Burroughs C3123 is a desktop calculator which has 12 digits. That's pretty cool, 12 digits, and looks like they're using some sort of vacuum fluorescent display thing. Oh, I will totally like to see that working. 12. These are not Nixie tubes, these are VFDs. Well, at least judging by how they look like. It's really hard to show you. Let's see, you see? I think you see them. So this gentleman, or this guy, was manufactured in 1971 by Burroughs Corporation, Japan. When I saw the name Burroughs, I thought this is like England or United States of America or something, but it's actually made in Japan. So I don't know much about this Burroughs Corporation, never heard about it. Yeah, but here we are. So this calculator is pretty heavy. It's a desktop version, and probably gonna be, I hope the VFDs are still like, I mean, not wow, whoa, oh, look at this. This is actually movable. Cool. So this is like a decimal points, I think, or something like that. Huh, pretty cool feature. I don't know what all this means. So this is pretty simple calculator. Looks like it has only like simple arithmetic functions right here. This is power button. This probably number of digits after 0, I assume. I don't remember. Maybe this is something related to memory. So obviously it's very hard to find schematic. A user manual yet. To find schematic even harder gonna be, but not much information is available. I'm gonna be looking more, and if I find something, I'm gonna post it on my website. Before we try to power this guy down, we would have to power up. I mean, we would have to actually take a look inside and see if it's actually safe to power up. See if the capacitor is not leaking, the short, there is no spillage, there is no corrosion. I'm pretty sure this power yeah, it's very flimsy. This wire, yeah, this plug is seen better days. I'm pretty sure it's shorted right here, so that has to be addressed somehow. Yeah, maybe I just, you know, I'll figure out something. Is there for the sake of authenticity, I'll probably keep that one, just make it properly terminated, nicely crimped and things like that. But first of all, we have to take a look what's inside. You know, if there is any corrosion, we have to clean it up before even think about powering up. Also, this wire is so looking crappy, and it's very stiff. So all right, looks like someone already done the job for me. Well, I think someone already unscrewed it, at least partially. So let's see what we see. Oh my god. All right. So here we are. Look at this beauty. I'm not sure if this is detachable. No, it is not. We have big Hitachi transistor, obviously transformer power supply, linear power supply. Now we see much better these beautiful VFDs. So yeah, this clearly VFDs. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them. And looks like there is a spot for one more right here. Interesting, it's missing. So yep. Or maybe it's just a digit, like, you know, like for example plus or minus, could be like that. But we have 12 VFDs. We have all bunch of discrete logic. Yeah, so we're definitely gonna get a little bit more insight. Here's beautiful Nichicon capacitor, you know, the how do you call it, axial or radial. I think this is radial, not axial. I'm mixing up stuff. So that, oh, look at this, there are two more spots for VFD digits and one here, but I see only one spot on PCB, so whatever it means. All right, a lot of discrete logic right in there. I'm curious, is there any kind of CPU this thing runs or not? Also, keyboard is connected through this, I hope this is detachable header. Yeah, so it would be easy to, oh yeah, it is. Oh, nice. That's a good news. Otherwise, it's very hard to keep it like that. I can just, ta-da! So this is detached. So this is like edge connector. Nice looking. Here is the edge. So that's cool. So we detach that. It looks like this power button is not detachable. So it's, but clearly unscrewable. So we, yeah, that's serious business here, because it looks like someone already did some splicing job here, or I do not understand. But anyways, oh, that was screwed right in here, but it's all busted. So what you're gonna do is gonna just unscrew this guy, this power switch. Doesn't have to be here for now. I hope I would be able to. Okay, so now we can separate top from bottom. Keyboard definitely seen better days. I see some rust. Okay, let me show you. So this keyboard, or those keys, well, this is keyboard actually, it's small but keyboard. It's seen better days. Look at this, how much rust is here. So I hope it's this all like this rust. So something was spilled on this guy for sure, some kind of gunk. So that has to be all taken apart. I hope those keys are taken apartable. Yeah, very interesting contraption, but we're gonna see how they organized or how they made. So those are two big switches switching different modes. I'm pretty sure there should be all fine with them. This is a little board here, so it looks like it supports more digits, right? So, but different board, definitely board is not. So also I'm looking at the board. Let me put this down. It has a lot of corrosion as well, like here, 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 here. So definitely whatever was spilling on the board, sorry, on the keyboards, was actually dripping onto the board. So this all has to be cleaned up. Even some gunk right here. So yeah, that's not looking too good. But at least everything is fine on this top board. Only this bottom board is to straight under the keyboard. All right. So this is connector between top and bottom board. So bottom and top, I mean, this is connected. I'm not gonna touch it now. All right, so let's see a bit closer at our power supply. And not much I can see here without some serious disassembly. Okay, it uses Nichicon capacitors. You probably need to kind of start unscrewing a little bit more. Yeah, we need to look in this needle a little bit more. So let's just, I'm curious if I can just have power supply be completely separate, completely separately tested from the whole rest of the sys thing, because that might need some. Oh yeah, okay, looks like power supply is somewhat detachable. Need to unscrew here. And wow, that's pretty cool. So it's actually marked here V75, HH, VGG, VDD, and have no idea what is yellow one. Ground probably. And look at this beautiful and very simple edge connector for the power supply. And here we are. We completely detached our module with the power supply. Completely detached. Very nice, very nice. Pretty heavy actually. It's like a chunk of metal, but we have power supply detached, so we can test it completely separately from the digital circuitry, which is awesome. Which makes sure that we're not gonna burn something when the power supply is bad. So this power supply supposedly should be fairly simple, but I see here H over here, so maybe it's, I don't know if it's high voltage. Yeah. VGG is ground and VDD is the 5 volt, I think, or whatever logic I see powered up. So it could be whatever 12, 9, depends what kind of logic is here. V75, potentially it is 75 volts to drive virtual fluorescent displays, potentially. I need to see, because right there we have 10 microfarad 100 volt capacitor just right here, so that's important indication that voltage here is not whatever 16, 12 volt, it's like it's way there. So that means this power supply is gonna be not just your super simplistic power supply. It could have transformer, could have several windings which actually provide some high voltages here. All right. Okay, so now we would have to take power supply apart to examine what's going on with the power supply components, specifically capacitors, and also to see, oh, how do you disassemble this guy? The transistor is actually connected by wires, so I don't know why it's not popping out. And someone was already into this because this screw is missing. I didn't unscrew that. It was not me. I didn't do it. And it slides. Oh, it's wow. Oh, I see corrosion. I see corrosion. And very funky fuse, which needed to be tested. This looks like it's a slow blow fuse of some sort. Yikes. So sign of such corrosion, I hope you see that, is indication of issue with capacitors, because where would they come from? So we have to double check all these capacitors over there. Yeah, because this could be an indication of that we have an issue with capacitors. They leaked. Also have to double check those fuses if they're still okay. All right, it's pretty tight package right here, but luckily our transistor is just removable, and it's only single transistor voltage regulator. I don't really see more there. I see some diodes. Maybe there is another transistor right there, a tiny one. Okay, there is a three fuses right here, 630 milliamp, 200 milliamp, but we have 700 installed, 200 milliamp, but we have 700 installed. Very interesting situation. And this one 0.5 amp. Okay, so let's remove all this stuff for now, okay, and while we're working with the power supply. All right, so I removed everything extra from the shot now. All right, so what do we have? So now we have only power supply here, and now we have to see this what's going on with the power supply. We're gonna check those fuses, we're gonna check those capacitors, and see if any other corrosion or any bad spot happening. Oh, this fuse as well. I'm gonna check this transistors. I think it gonna be fine. All right, I'm just looking how else I can unscrew the board. It's really hard to say. There's only one screw here, so we're gonna just unscrew this gentleman right here. There's something else holding the board. What can that be? Okay, maybe this cable. I can use this guy to... Okay, that was right. Maybe this, have to unscrew this grounding point right here. Nice copper washer, like a washer and a screw, or maybe bronze screw. Still, but at least we have access right now to the back side of the board. Okay. It says HEC011 H3A, means really nothing. There is no any other like brand names or anything like that. Okay. So we have access to capacitors. We can try to test them with my capacitor tester thingy, but I would have to replace leads here. So now when we have better access to the bottom of the power supply board, let's try to test this big capacitor and find the right pins. Okay, so seems like for this such a big capacitor, 1.26 ohms ESR is a little bit too high. It should be lower, but it's still not too crazy bad. It probably needs replacement, but I don't have axial capacitor. So then I tested all other capacitor. So here I'm testing every other capacitor, and the ESR is actually relatively okay. Obviously they are old, and for good measure they should have been replaced, but again, not having the axial capacitors not gonna help me here, so I'm gonna leave them as is. Okay, done with capacitors. Let's check those fuses. Looks like they are a little bit corroded right here, those contacts. But anyways, fuses should be fine. Okay, the first fuse seems to be okay. Okay, let's do these two ceramic fuses. Oh, here we are. Looks like it's not so good. And the next one. Is not good as well. So here we are. So two fuses are gone ski. Also, I'm gonna pull out the fuse which seems to be working, and double check on the bench as well. Yes, it confirmed that the fuse is fine, and looks like I have to clean the terminals of the fuse holders, or yeah, because looks like they are corroded. For cleaning fuse holders, I decided to use alcohol and just a regular toothbrush. I did a lot of brushing to make sure the all corrosion is gone. Then I use more alcohol to rinse. Then I use another toothbrush to kind of clean up the residue. So it's end up being relatively nice and clean, and I think that's gonna work. And because I didn't see the actually capacitor electrolyte leaking, so I assume that that was just because some atmospheric effects, like, you know, humidity in the in the way that thing was stored. Okay, so looks like we're done with cleaning. Let's put those replacement fuses. Oh no, before we start dealing with replacement fuses, let me replace this. Let me check first this horrible plug and see what we have inside there. And because I don't think it's safe, judging by the blackness over here at the end of it, that it's safe plug. Let me see, and let me open it and see what we're gonna have here. Okay guys, I don't even know what to say. This is look horrible and definitely shorted. The safety level minus 100%, or even lower than that. So this definitely has to be addressed, replaced, or probably addressed. Yeah, this is definitely not gonna work. I hope someone, you can burn the house with this. Okay, we have to address that for sure. Alright, look at this horrible thing. This is crazy. So yeah, definitely have to address this plug before we go any further. I don't even, like, I'm kind of stumbled. I think I have to reuse plug from somewhere else, because this is just nuts. I don't think I have any ready to use plugs like that. Let me think about it. Okay, for now I decided to just unscrew it. Let's then think about what can I do about it. Oh, it's just falling apart. Okay, I can clean. Well, it's sort of kind of handy to have something like that, but it is dangerous. Yeah. Oh damn! I don't really have any. Like I can just take a computer cord and just, you know, splice it and do this, cut the other end. But I'm kind of hesitating. Alright, my friends, so I actually decided to go ahead and use this one, and then when I actually figure out that stuff working for real, I'm gonna chop this off and I'm gonna use this one. But before I know the stuff is real, there is no point to actually destroy perfectly good cable. Okay, so I still can do it nice and safe. Just recycling this old plug. Alright, let me do it. Alright guys, so I think I've done much better job here. I also tinned those wires so that they're not gonna fray and like contact each other. Alright, so let's just yikes, put this back on. Okay. It's tough. Alright. Okay, something like that. Also, I clean up those prongs, like sanding them a little bit. So now, let's do this strain relief thing. Yes. Have to really tighten this thing up. It's like grotesquely large screws actually. It's still kind of moving. Yeah. Let me use the bigger screwdriver. No, it's too... Oh, that's better. I feel like I need to like cut those screws. Look at this, like it's retarded. It's like, what the hell? You cannot just cut, you can just scratch yourself. All right. Okay, here we are. Well, okay, so this is done. Then I deal with the cleaning up of this cord later. Okay, fuses. Here's my fuse collection right here. And we need this 200 milliamp. Right, so we have 200. I'm not sure if it says 200. It says nothing really. 250 volt, 0.2 amp, nice. Put it here. Another 0.2. Put it here. Okay, we need to also check the big one, because I'm not really sure if that one is good. Okay, this one is good. Wait, what? What's this 12 ohm stuff? Yeah, interesting. Okay, it's bad contact, I guess. Okay, the fuses goes to the side. This fuse is fine. Let me screw this board back and let's try to power it up. Just I need to, because it's all metal jaws around the board, so I don't want to like short anything. I'd like to. Hey, there are some notches and it just doesn't fall into them. Okay, that's better. What kind of screw was here? I'm curious. Bigger ones. Okay, let's try that one. It's too big. Some for grounding. Okay. Oh shit. No, where did this came from? Oh yeah. Okay, you see guys what's happening when you start freaking finagling with this stuff. Now I have to solder it. And piled up all tools in one spot. It's not a problem. Okay. I think that was like that. What's interfering? Where's this guy? Has to go. Okay, here we are. Alright, so this is all assembled. I'm gonna put this also grounding point back on. Test. Okay, just checking my microphone, just to make sure. Alright, so okay, we have it. So this is our power switch. We actually has to be careful with it because it just live here in this stuff. Yeah, someone definitely was here. So whoever did, he just shorted that and put the you see. So like, it just switches on neutral, but live is actually connected. So wow, this is interesting. So I have to kind of address that as well, just to make sure we are okay. I don't even know where is. Okay, let's do on. So I powered it on, and let's power it up. All right, nothing has blown. That's good news. Okay, let's do power on again. Let's take our voltmeter and measure some stuff. Let's do DC first. I do believe there is gonna be a mix of DC and AC here. Okay, this is dangerous. Go away. Okay, here we are. It does have voltage here. Minus. Whoa. Interesting. And I believe these two is AC, judging by at least the text. Wow, 5 volt IC, interesting. So we have some voltages here. Let me power it up, power it down. Let me actually try to connect it to the main chassis board and see. I believe those voltages are fine. By the way, this thing is not keyed in. You can connect it like this, or you connect it upside down. Obviously, cable goes that you can connect it only like in this way, but still, that's just quite. All right, moment of truth. Ha! Have some digits, 0, 0, 0, 0, 12 zeros. Looks like some of them are not, you see this is brighter, darker, 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 brighter, brighter. So some of them are probably already kind of quite dimming down or getting dim. But nevertheless, all 12 digits are working. Yeah, that's very nice. It's good to see. I'm curious about this mesh. I'm curious why it's here. So in front of these digits there is a mesh. Hope it's not like high voltage or anything. No. I guess it's potentially this is kind of RF shield to prevent like some EMI coming from this. I don't know, maybe. But yeah, or prevent people poking. But there is a screen also. All right. So this is good news. So this thing is working essentially. Power supply, we fixed replaced fuses, we fixed power supply. So power supply seems to be doing okay. Still, I have to take it apart like completely because I need to, first of all, get to this bottom board and clean it up from all this corrosion. So there's lots of corrosion here. So that has to be done. But in order to do that, I need to like essentially take it all apart. That's been interesting thing, but at least we know that power supply is good, so that's gonna be our first step, and I'm gonna stop right here. We're gonna continue in the part 2. So guys, if you wanna see more of this sort of video, please stay tuned, please subscribe. I'll go in the part 2 when I deal with the board, and then gonna be part 3 when I deal with this corroded keyboard, because clearly we have a lot of corrosion here. So okay, I'm happy. This thing is at least somewhat alive. Yeah, so I'm feeling positive we can fix it. Alright guys, see you next time. Stay safe and ciao.